This is Geometry, Section 3.3, Proving Lines Parallel. So this lesson is basically the opposite of the last lesson. The last lesson we had a bunch of conditional statements about parallel lines. So we said if we have parallel lines and corresponding angles are congruent, if we have parallel lines, alternate interior angles are congruent, if we have parallel lines, alternate exterior angles are congruent, and if we have parallel lines, same side interior angles are congruent. Today, we're basically talking about the converses of those four statements, and we're going to see that those are also true. So yesterday we started with knowing that the lines are parallel and then saying something about the angles. Today we're starting with knowing something about the angles and then saying whether or not the lines are parallel. So the converse of the corresponding angles theorem, like I said yesterday, we said if we have parallel lines and corresponding angles are congruent. The converse of that would be if corresponding angles are congruent, then we have parallel lines. Same thing for alternate interior angles. So if, this means the same thing as above, so if alternate interior angles are congruent, same as above, then parallel lines, same as above. Same thing for alternate exterior. If alternate exterior angles are congruent, then we have parallel lines. And if same side interior angles are supplementary, not congruent, supplementary, then we have parallel lines. So, if I have these two lines right here, M and P, I'm trying to decide whether these lines are parallel. Well, these two angles right here, one's 45 degrees and one is 46 degrees. These are alternate interior angles, but they are not congruent. Therefore, these lines are not parallel because our alternate interior angles are not congruent. So if the alternate interior angles are not congruent, then the lines cannot be parallel. Over here, we've got same side interior angles. They're on the same side of the transversal inside the two lines. So same side interior angles should be supplementary, like we said up here. So I have to see if 91 plus 89 adds up to 180, which it does. So since our same side interior angles are supplementary, yes, the lines are parallel. Down here, we've got alternate exterior angles. They're on opposite sides of the transversal outside the two lines. They are not congruent, so these lines are not parallel because alternate exterior angles are not congruent. Here, I've got corresponding angles. These are both on the bottom left position here. Corresponding angles need to be congruent for parallel lines, so these are not parallel because our corresponding angles are not congruent. Next it says describe the angle pair and find the value of x that will make the lines parallel. So now we have to say, alright, well what kind of angles do we have? Should they be congruent or supplementary? What value of x will make that happen? So here I've got corresponding angles. They're in the same position. Corresponding angles. We know corresponding angles need to be congruent in order for these lines, K and M, to be parallel. So I have to set those things equal to each other. 2x plus 30 should be the same as or equal to 120. So I would subtract 30 and get 2x equals 90. I would divide by 2 and get that x equals 45. Over here, we've got same side interior angles. They're on the same side of the transversal inside the two lines. So these two things have to add up to 180. So 4x plus 32 plus 80 should equal 180. 80 plus 32 is 112. So 4x plus 112 should equal 180. If I subtract the 112, I'm left with 4x equals 68. Divide by 4, and I would get that x has to equal 17 to make these two lines parallel. Over here, we've got alternate exterior angles. They're on opposite sides of this transversal, and they are outside these two lines. So alternate exterior angles should be congruent. So again, I'm going to set these two things equal to each other. 7x minus 12 equals 5x. Get all the x's on one side by subtracting the 7x. 5x minus 7x is negative 2x. Divide by negative 2. Negative 12 divided by negative 2 is a positive 6 for x. Again, determine whether the lines are parallel and explain the answer. So, I'm trying to see if A and C are parallel to each other. It might help if I extend these lines just so I can get a better picture of what kind of angle pair these two things are. So, if I look at this angle right here would be 91 degrees because these are vertical angles. This angle and this angle are alternate interior angles, so these two should be congruent if these are parallel lines. So if this is 91, these two together have to add up to 180. They have to make a straight line, but 91 plus 91 does not equal 180. Therefore, these lines would not be parallel because our alternate exterior angles, or excuse me, our alternate interior angles are not congruent, because if this is 91 right here, this cannot be 91 right here. So our alternate exterior angles cannot be congruent. Alternate interior angles not congruent. Okay, here, this is kind of a weird thing happening here. So I've got these two lines that look like they might be parallel. We have to decide if they are or not. This thing we've never really seen before, but if I just kind of ignore that thing and look at this angle as a whole, this angle as a whole and this angle are alternate exterior angles, so they should be congruent to each other if the lines are parallel. So if I just add these two numbers together, 34 and 88, I get 122, which is the same as this angle right here. So our alternate exterior angles are congruent here, which means that these lines would be parallel. Decide whether the equation is correct or incorrect and give a reason. So first thing we have to notice here is that none of these lines that we're given are parallel. We are not told that any of these lines are parallel. If they were, we would have to have marks like this, little triangles on these lines showing that they are parallel, but we don't have that here. So we don't know if any of these lines are parallel. Therefore, we can't say any of the things that we learned in the last section, like corresponding angles are congruent, alternate interior angles are congruent, same side interior angles are supplementary. We can't say any of those things if we don't know the lines are parallel. So here it says a student wrote that 3x equals 120. Is that true or not true? Well, these are corresponding angles, but like I said, we don't know if these lines are parallel. So this is incorrect because we don't know if the lines are parallel, which means we don't know if the corresponding angles are congruent. Here, student wrote the same thing, 3x equals 120, but here we do know that these have to be congruent to each other. This is correct because these are vertical angles, and vertical angles are always congruent. Vertical angles are always congruent. Here, 4x and 80 make a linear pair. 4x plus 80 equals 180. Straight line, linear pair, always equals 180, whether the lines are parallel or not. So this is correct because a linear pair always equals 180 degrees. Here, however, we've got 80 and 4x, which are same side interior angles. The student wrote that 4x plus 80 equals 180. Again, this is incorrect because we don't know if these lines are parallel, so we can't say anything about the same side interior angles. Don't know if the lines are parallel. Alright, and a proof, quick proof. So we've got angle 1 congruent to angle, angle 1 congruent to angle 3, angle 2 congruent to angle 4. So that's our given. I'm just going to draw an arrow here. This is given to us. Then it says angle 3 is supplementary to angle 4. Well, those are a linear pair, so those are supplementary. It says angle 1 is supplementary to angle 4, and then angle 1 is supplementary to angle 2. Well, those are nowhere near each other, and we don't know if we have parallel lines, but since we knew 1 was congruent to 3 from up here, we could just substitute this in. And then since we know 2 is congruent to 4, we could substitute 2 for 4. So this is just substitution. Then, our last statement, S parallel to J,